Hello, and thank you for joining this presentation. I'm Rene, a PhD candidate at the German Aerospace Center and the Technical University of Munich, and this work is done in collaboration with Andres Camero and Xiaoshang Zhu, that are my collaborators and supervisors in both institutions. Before diving into the core of this presentation, which is about hyperparameter optimization, I would like to say a few words about automated machine learning in general. And as you might already know, machine learning pipelines are already widely adopted in various fields and industry. Basically, wherever there is vast amounts of data from which we want to make decisions. And AutoML as a field helps providing algorithms that would make the work easier. It's involved in various stages of machine learning pipelines. In our case, we're interested in the stage of model selection, where the subfield of hyperparameter optimization and neural architecture search are operating. In our case, we're more specifically interested in the topic of, in the general problem of hyperparameter optimization, where given a hyperparameter configuration space and a performance evaluation pipeline and a budget of iteration, the objective is to find the hyperparameter configuration for a decision-making algorithm that provides with the best performances on unseen data after training and evaluation. This is already a well-studied subfield of AutoML. However, the understanding of the influence of the various components of HPO on the final performances is yet to be explored, or our understanding can be improved. In our case, we are asking ourselves the following question. Can the landscape of HPO be biased by the pipeline used to evaluate individual configurations? Or in other words, can the process of hyperparameter optimization be influenced by the design choices made when deciding how to evaluate configurations? And if so, can we measure this influence? In order to answer this question, we decide to make a fitness landscape analysis of various hyperparameter optimization problems. More precisely, the scenario of tuning the hyperparameters of an image classifier on various instances, including Cipher10. And given this setting, we then generate the respective fitness landscapes and analyze features from these landscapes. On the instance of Cipher10 shown on the left figure, here you can visualize the fitness distance correlation for its fitness landscape. And despite the absence of correlation between the two variables of interest, we observe that the fitness behavior, the hyperparameter configuration space provides with a very diverse fitness behavior on this task. On the other hand, when looking at the task of SSIMNIST, we identify a very interesting phenomenon, which is the following. So we observe that very diverse hyperparameter configurations provide with the same fitness. And when looking at the data for this instance, we observe that we identify that this behavior is the one of majority class predictors, a phenomenon that is enabled by the choice of the metric here, that is the classification accuracy, that is not able to deal well with class imbalance. Next, we look at how this evaluation pipeline malfunction might affect the deployment of HPO local search-based strategies. And we identify that in the case of malfunction, the respective fitness landscape is more rugged, basically with more local optima, a phenomenon that would make the deployment of local search more difficult. With that, I would like to thank you for your attention. Please feel free to reach out if interested. Thank you very much.